Why do boats float on water? A boat floats on water because it displaces a volume of water that weighs more than the boat does. A boat exerts a force downward and the water it touches exerts a counter force upward. The boat floats when the two forces are equal. This method of flotation favors boats made of light materials and with broad undersides. When a certain amount of water is forced out of the way, the boat feels upward pressure equal to the weight of that water. If a boat is filled with water, the weight of that water will increase the weight of the boat, and less of its flotation can hold the boat. The boat would sink anyway. If the boat's overall weight would equal the uplift force or the upward thrust of the water, the boat will sink only if the upthrust of the water becomes exactly equal to its weight or if it has no air left in it. On the physics of a boat's flotation, if the weight of a boat is lower than the maximum volume of water that it can shift outwards or push outwards, it will float. In others water, the object is floating because it is lighter than the volume of water that it is pushing aside or pushing aside. For a boat to float, it must have an overall density that is lower than the density of the water in which it is floating. The average density calculated from the total volume of the RMS Titanic, which includes components and air, must be lower than the same volume of ocean water. The closer a ship's overall density is to that of the same volume of water, the greater amount the ship will float. Eventually, the boat's average density will be greater than that of ocean water, and the ship will start sinking. Eventually, a boat becomes so filled with water that it cannot push enough of it away, even as it is completely submerged, that it can remain afloat and will sink. Little of the boat's most needs to be submerged. Very little of the boat has to sink in water before the boat weight is moved. The boat floats and partly sinks according to its weight and the amount of weight it is carrying. The greater the total of those two weight, the lower it will be in the water. It is simple to know the weight of a boat, but difficult is calculating how much volume of a boat it would have set below water and created a buoyancy force to keep the boat above water. In other words, the boat is floating because it is lighter than the volume of water that it is pushing against or pushing against. Boats float because even though they are heavier, they are still lighter than the volume of water needed to fill a boat. Larger boats can float despite being heavier because they have more water displacement. A massive boat, however, will float because although it is heavier, it has a tremendous amount of water displacement, which is heavier. If you filled a commercial fishing boat with that same weight, it would float because it has a lot more buoyancy or ability to hold a larger load and displace a larger volume of water than it does, because a larger boat which has more weight is displacing more water. It has a higher buoyancy and then a rowboat. As the ship moves through the ocean, it pulls on the ground and displaces a quantity of water that it is the same weight as the boat. How floating physics works. If anything is floating, that is because the amount of water being pushed out that is heavier than the things at the top. Each square inch or square centimeter of a boat underwater has a water pressure pushing on it, and that combined pressure is what makes a boat float. The buoyancy force is a bit trickier. It exists because a boat takes on some of the places in the water in which it is floating. As a ship moves, or to put it plainly, moves the water away, the moving water wants to move back into the place where it was. But since it is where the flow boat is right now, the water is pushing the ship up. Generally, apart from slightly different water resting levels, you do not see a lot of differences between the same ship in different environments as far as floating is concerned. There is always some amount of water that is being moved around to allow boats or even a lot bigger ships such as aircraft carriers to float. Also, boats are designed especially to be able to dispense enough water to ensure that they can easily float. By computing all of the values, you can figure out whether the boat will displace enough water to ensure that there is enough buoyancy to maintain the boat's top weight afloat. What this realization means at sea: this is a boat weighing, say, 1000 tons will sink before the boat that weight 1000 tons displaces 1000 tons of water. If downward pressure is smaller than buoyant pressure, the body is in a liquid will float.